So the next unit we're going to move to is chapters 2 and 9. We're going to do chapters 2 and 9 together. 2 deals with describing matter. It gets into mass and volume and different descriptions of matter itself. And chapter 9 deals with chemical names and formulas. And I think it's important to talk about chemicals and names and formulas, and certainly get a little bit of periodic table information under our belts before we move too far. It is as we see, we're going to be putting these together, but also kind of separating. So we'll take a look at them together. I'm going to move right on to chapter 2, and this deals with describing matter. First of all, it is important to know that what mass is. Mass is the measure of the amount of matter an object contains. So you've heard it before. The mass, our mass, let's say our bodies, the mass does not change whether we're here on Earth or if we're in space on the moon. Obviously, gravity is different in different locations. A lot less gravity on the moon, but with less gravity there, we may have a different weight, but our mass is still the same, and that's a measure of the amount of matter an object contains. When you talk about volume, volume is the measure of space occupied by an object, the amount of space. And of course, when you start to talk about mass and volume, the next thing you talk about is density. And density, of course, is the mass over the volume. You can determine how dense an object is by dividing the mass and the volume. Of course, the formula here, I just wrote it out, but D is M over V. I know that some of us have heard and seen before. It's a great way of remembering it. You draw your little heart and then write the line through it. So you've got your mass and your volume. That's a great way of remembering the formula for density. Of course, the density formula also can show you what the units are in. Mass is in grams, and volume usually in milliliters, could be centimeters cubed. If we're using SI units, it would be centimeters cubed. But notice the label for density is grams per milliliter or grams per centimeters cubed, meters cubed, which makes sense because that's the formula for density. So there's your density formula. We're obviously going to have problems to solve with that. Okay, moving right along, states of matter. Rapidly going to go through this right now. There's going to be other chapters where we deal with the states of matter. But of course, states of matter are your solid, which of course there's a definite shape and volume, a liquid which has an indefinite shape yet a fixed volume. So indefinite shape meaning you can pour a liquid into a skinny tall graduated cylinder or a round bottom flask that's very circular looking. Still you pour it in. Indefinite shape, it will take that shape but the volume is fixed. Gases, on the other hand, are indefinite shape and an indefinite volume. It'll take the shape and the volume of the container. So if you have a round flask, let's say, you can pour your liquid in there. It'll take the shape of the container, round. If I poured this now into a graduated cylinder, obviously it would take that skinny shape. That's your liquid. Obviously gases, if I have my round bottom flask again, if I put a gas in there, then there will be gas particles all over the place, whether it's up on top or the bottom. So it takes the shape and the volume of the container, the full volume. Here I may notice I may have less than a full volume in a liquid. All right, so those are your states of matter. Of course, a solid, obviously a solid has a definite shape and volume. All right, so those are your states of matter. We're going to get into a greater detail of those as we move through the year. Moving quickly to the next, a pure substance. Pure substance is something like an element. An element, any element off the periodic table. You see hydrogen, helium, etc. If we go through the order, hydrogen, helium, lithium, beryllium, boron, carbon, etc., etc. All those elements off the periodic table are pure. In addition, compounds are pure. Anything that is just a straight compound, just pure water, not water out of a tap, which may have different substances dissolved in it, different metals, fluoride, etc., etc. that would not be a compound. A compound is a pure H2O, CO2, etc. So again, pure compounds are pure substances. A mixture, we have two different types of mixtures. We have heterogeneous, which you can see the difference in the components. Example, like a garden salad, sand and water, etc. Where you can see the difference in the components, or a homogeneous or homogeneous, which appears the same throughout. Anything that appears throughout the same throughout the mixture is considered a solution. A solution like salt water, Kool-Aid, Jello, where you don't see the different things in it. Those are homogeneous mixture, or homogeneous mixtures. Obviously, by definition, hetero means different, and you can see the difference in the components, versus homogeneous or homo means the same. The same. So again, I mentioned a hetero versus a homosexual couple. Heterosexual couple, male and female. Homosexual couple, male male or female female. So again, the term hetero and homo, the prefixes, mean different and same respectively. All right, I do want to show now quickly how we separate mixtures versus pure substances. When you separate a mixture versus a pure substance, it's different. A mixture, obviously, filtration. You can separate a heterogeneous mixture with filtration. Sand and water, pour it through a filter, the sand's going to stay in the filter, the water will go through. You can't do that with like salt water. Salt water, you may need to use different techniques. Distillation, which would be how you would do that. Distillation would be being able to separate a liquid that has something dissolved in it, like salt water. Let's take a quick look at a video here.
It would have been good to record while my lighting up the flame. Alright.
And that doesn't necessarily need to have any volume, but basically what we have here in the blue flask is some water, and again, all I did here was take some water, put some blue food coloring,
take a look at the temperature.
Yeah, I'm zooming in on you, flaming it up right now.
And there's some salt in there as well.
Thermometer is
now,
on this side.
This is a distillation apparatus. Basically, there's some water running through the tubes. I don't believe I can use my cursor. Let's see if I can. So, heating up right in here. You can see the temperature, and the temperature itself will not get higher than 100 degrees, because once you get to 100 degrees, then water boils, and the water will boil off. Hopefully we can see a little difficult to see this. So in here, I have water, and it's just running from the tap, and that water is cooling down the steam. So once this liquid right here starts to boil, it'll go up. We're just taking a look. Hopefully we can see the temperature.
No, I'll get Dawn in the background.
Sorry, we get you in, Dawn.
Alright, it's way going up now. Okay.
Once we start to see some bubbles and boiling, then the steam will be released. Obviously, water boils at 100 degrees. Water that has
Lights off, so now go
in
take
it
a look at the temperature.
will not boil at 100, well,
This
the
is
higher
pretty
temperature.
legit right
So
there.
the water is now boiling. We should be starting to get some steam. You can see that there's some condensation because it's hitting the flask and condensing right on there.
That's good right there.
But I imagine
Get close, you might be
get
able
any
to
kind
see
of
now
movement
without
of
the
this.
light up. Water, it's focusing behind. There we go.
And it's not going to go above 100 because it's going to allow. We're really just taking the temperature of the steam.
I can see it good.
And since we're taking the temperature of the
Now
steam,
go down and look at
it's
its
100
100.
degrees.
And look over here now.
Notice
And
the
across.
thermometer is not in the liquid. It's in the steam, 100 degrees. And now, that water is going through this tube. Like I said, this water right here is just going to cool off the steam, the vapor,
Get underneath
the
it, you can
gas,
see the water.
and now we're going
It's
to
kind of-
get,
Yeah, I'm trying to.
Fuzzy.
barely see, you can see some dripping there. You'll see some dripping now, is just forming some water. Notice that the liquid that we're collecting in this new flask is clear. And again, the reason that it's clear
Chemistry
in
unknown.
there is because we
For some
are
reason it's
filtering
super
it,
bright.
distilling it, I should say.
Yeah,
Distilling
No,
it
it's way too bright.
from-
Like the way it.
the full blue liquid which has it.
There we go.
So you can
Is that pretty
see
good?
Yeah.
Getting reflection off the glass.
Yeah,
the
yeah.
clear liquid. So we filtered it. Distilled it. Cool.
It would have been good to record while